Hi guys, I'm going to talk about my final project of class DA5030. I got my data set from UCI Machine Learning Repository, which is about cervical cancer, and there is almost 900 records and 36 fields in my data set, and most of them, and there uh, uh, numeric and factors variables in my data side. So the numeric variables is just about like patient's age, the first sexual intercourse age, the number of the sexual partners, and smoke years, like this. And the factor variables is mostly about patient's medical history, like any STDs, and one means yes, zero means no. In this exercise. So in terms of my business problems, so because cervical cancer is the fourth most common cause of death in women and early age cervical cancer generally produce no signs of symptoms. There are numerous factors that contribute to the probability of the cervical cancer. There are four target variables in my dataset: Hinsman, Schiller, cytology, and biopsy. In this project, at the center to diagnosis the cervical cancer is two of target variables positivity. In order to make the diagnosis efficiently and precisely, using machine learning to build a model which could predict whether the patients have cervical cancer or not. Um, so in terms of how I export the data, I for those numeric data, I just plot histogram and box plot. In this step, I didn't remove any of the data because the data size is just like record, so any of them could be possible. Um, and I so in terms of what kind of transformation I did. So firstly, I selected data. I remove two columns of the in this size because almost all of them is missing value. So I think it's not very big important for this project. So hold on. Oh, I think I have run this code before. Sorry. In order to clean data, so I convert data to a Proj data type. So there is some numeric data in a raw data set is a factor. So I just convert them to appropriate data, and there is a lot of question mark in my data set. So in this step, I also convert them to an A value. We can take a look here, and I uh, and then I try to find outliers and remove them. So I did normalization, this core normalization here. Uh, um, I remove all records that absolute this score larger than 3, and also I filling main values to NA in the numeric column. Because there are a lot of NA value in my factor variables, so I create dummy code for them. Like what I said before. So there is four target variables in my dataset. So in order to make this project easier, I just made the rules that if two or more of target variable is positive, then target variable is positive unless negative. So I just create a new column. It's a target and remove the original four target variables here. And also, I remove redundant variables here because a lot of variables, factor variables, just have one level. Um, and Also, I did the correlation and or collinearity analysis here. Um, so after this, I just have about 400 records and 15 variables. And also, I also did the PCA analysis. So in the modeling part, I built three models. It's KN logistic regression and decision tree. So the result I wanna get is a class instead of a number. So it is a very important standard to choose model, and so KN are defined according the texture. KN are defined by their characteristic of classifying unlabeled examples by assigning them the class of similar labeled examples. So apparently, KN is very fit for my data set. And the reason why I pick logistic regression is that it is used to model the probability of certain class of event. Logistic regression is a statistic model that in its basic form uses a logistic function to model a binary dependent variable. Although many more complex extension exist, it's very good for MetaSci. So for decision trees, it is also a powerful classifier. Which utilizes a tree structure to model the relationship among the features and the potential outcomes. So in this part, I need to split my data set. So 70% of my data size is train, and the other data set is a test data set. So we can take a look of my model. So in K nearest neighbors here, there is a 499 samples to join. And 40 fields are being used, and the results to class. And we can see that here, when k equal to 9, accuracy was used to select the optimal model using the largest value. So I also did the twin model here. So when k equal to 43, you can get an optimal model. So in this step is logistic regression. So there is no R squared in multiple regression to measure a model is bad or not, is good or not. So so for classifier, we just create the matrix. But I will talk this in evaluation part. So we can see that this is the argument of the formula, and you can see some of them is significant. Uh, the last model I chose is a decision tree. So also we can take a look. So in the evaluation part, I just create a tail confusion matrix here. We can check. You can take a look of my true positive, true negative, for positive, and for negative here, and the accuracy is very high, and we also get a 95% confidential interval here. So also I did tenfold cross validation here. You can see the accuracy is very high. So just like in a model is the logistic regression. We can see DS cancer and DS HIV is pretty significant here, but I'm super surprised that the HPV is not very significant here, because there is some research about the cervical that HPV is kind of versus to cause cervical cancer. So maybe there is something. Maybe it's because of my DSS uh, is not big enough, and there is not very so much positive records uh, to to the model to let them know how to predict the result. So it's also the decision tree. The actually the accuracy is the same. So um, let's take a look my example models. So since they all have a pretty good accuracy, so I create an example learner. I just combined of them. I just use a boosting method to build my model. It boosts the performance of weak learners to attain the performance of strong learners. So this is the result. Also here is the confusion matrix, and here is the accuracy. So in this class, the key lessons I learned is not except those how to train a model, how to test a model, and some algorithm of the machine learning. I also learned is that do not assume do not assume your result. It could have influence of the outcome. So thanks for listening.